one of the great things about chemistry is the periodic table. Once you know how to use the periodic table, you can use it to explain the chemical reactivity of any element in the whole universe, even if you've never seen it before. So here are the first 18 elements, starting with hydrogen, going through helium, through lithium, all the way down to argon. And chemistry is just about the way that electrons get transferred or shared between atoms. And once you know how electrons are shared or transferred between atoms, you can pretty much explain the chemistry of anything you'll ever come across in the world. So to work out the number of electrons that an element has, we look at the atomic number. And remember, the atomic number is always the smaller of the two numbers inside an element's box. And these are highlighted red here. So hydrogen has got 1 electron and 1 proton. Helium has got 2 electrons, 2 protons. Carbon got 6 electrons, 6 protons, all the way through to argon that's got 18 electrons and 18 protons. So electrons go around the outside of the nucleus, and they're usually described as being in shells, and we show shells as circles, and they look a bit like how you would draw the orbits of a planet around the sun. So here we have hydrogen. Hydrogen has got 1 electron and 1 proton. Helium has got 2 electrons and 2 protons. So we're going to draw the electron in for hydrogen. So the electron we're going to put is there. And helium has got 2 electrons, so we can draw them in 1, 2. Now, because it gets a bit messy, and because chemists are really interested in electrons more than protons, more than neutrons, what we tend to do is we tend to draw the nucleus as just this chemical symbol of the element. So if we look at this, hydrogen has got 1 electron, helium has got 2 electrons. What happens when you go from helium down to lithium? Well, when you go from helium down to lithium, you start a new row or a new period. And every time you start a new period, you start a new electron shell. The first shell can take 1, 2 electrons. So when you go from 2 electrons to 3 electrons, the third electron goes in a new electron shell, and you circle around the outside of the nucleus. So look at this. Helium's got 2 electrons, 1, 2. Lithium has got 3 electrons. Now, that's like helium, but it's got this extra electron, and this extra electron is going to go in the second shell there. Okay? So we've gone from helium to lithium. We've started a new row, a new period, and that's why we have to have a new electron shell. Now, electron shell can take 1, 2, 3, 4, 5, 6, 7, 8 electrons before it gets full. The second electron shell can take 8 electrons before it gets full. So lithium has got 1 electron in its second shell. Beryllium has got 4 electrons, and these are arranged 1, 2 in the first shell. There are 2 electrons left. These go in the second shell. Neon has got 10 electrons. The first shell can take 2 electrons, which means there are 8 electrons left. 1, 2, 3, 4, 5, 6, 7, 8. We say neon has got a full outer shell of electrons, because remember, the second shell can only take 1, 2, 3, 4, 5, 6, 7, 8, and neon has got 1, 2, 3, 4, 5, 6, 7, 8 electrons in its outer shell. What happens when we go from neon to sodium? Well, just like before, when you go into a new row, a new period, you have to start a new shell of electrons. So going from neon to sodium, we've gone from 10 electrons to 11 electrons. The first 10 electrons of sodium are like neon. So it goes 2 in the first shell, then 1, 2, 3, 4, 5, 6, 7, 8 electrons in the second shell, and there is 1 electron in the outer shell. When we look at magnesium, magnesium has got 12 electrons. That's 1 more electron than sodium, so it's now got 2 electrons in its outer shell. And then we go to argon. Argon's got 18 electrons, so it's got 2 in the first shell. The first shell always takes 2. It's got 1, 2, 3, 4, 5, 6, 7, 8 electrons in the second shell. So that's 10 electrons that we've marked so far. That gives us 18 minus 10 is 8, which means the outer shell of argon has got 8 electrons. 1, 2, 3, 4, 5, 6, 7, 8. Sometimes chemists don't want to draw all of the shells and all of these bits here. So what we'll do is we'll write the electron configuration as numbers. So using lithium as an example, we write the electron configuration as 2,1. 2.1. That means there are 2 electrons in the first shell and 1 electron in the second shell. Neon is 2,8 because there are 2 electrons in the first shell and 1, 2, 3, 4, 5, 6, 7, 8 electrons in the second shell. If we take sodium, it's 281 because there are 1, 2. The second shell contains 8. 1, 2, 3, 4, 5, 6, 7, 8. And the outer shell, the third shell, contains 1 electron. Look at, for example, argon, this stuff here. It's got 8 electrons in its outer shell. It's got 3 shells. The important thing is groups and periods. So the group number 1, 2, 3, 4, 5, 6, 7, that's usually written as 0 or 8 going across. The group number tells you the number of electrons that that element has in its outer shell. So all of these things here, lithium, sodium, potassium, rubidium, cesium, francium, have all got 1 electron in their outer shell. Everything in group 7, fluorine, chlorine, bromine, iodine, astatine, have all got 7 electrons in their outer shell. As you go, the rows going across are called periods, and that tells you the number of shells that there are. So hydrogen and helium are in the first period, so they have 1 shell. The second period, lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, neon, have all got 2 shells. The third shell, sodium, magnesium, aluminium, silicon, phosphorus, sulfur, chlorine, argon, have all got 3 shells. So if we go back, so argon has got 8 electrons in its outer shell because it's in group 0, which is also called group 8, and it's in the 1, 2, third period, so it should have 3 shells, which it does.